Turn to your next blank page in your journal, put today's date at the top, and put today's title, Lesson 4-2, Ratios and Rates. Does everyone remember what a ratio is? A ratio is just a comparison of two numbers. We have two new vocabulary words to add today, and they are rate and unit rate. I need you to know that both rates and unit rates are kind of ratios, but they're special kind of ratios. So let's look at a rate. A rate is a ratio of two measurements having different units. For example, I could compare miles to gallons. I am using two different measurements, miles which measures distance and gallons which measures capacity. So I have two different units, therefore it is a rate problem. The next is a unit rate. A unit rate is a kind of rate and a ratio, but it must have a denominator of 1. In our journals, let's write down an example of a ratio, a rate, and a unit rate. So let's start with the ratio. We talked about ratios yesterday, so an example of a ratio could be something like 3 apples over 5 oranges. Then a rate is a specific kind of ratio that uses two different units of measurement. For example, I could say that we drove 200 miles in 5 hours. Then a unit rate is a more specific kind of rate that has a denominator of 1. So I could say that we drove 21 miles on 1 gallon of gas. So a unit rate is a kind of ratio because I'm still comparing two numbers. A rate is also a kind of a ratio because I'm comparing two numbers. But since I'm using different units of measurement like miles and hours, miles and gallons, these are more specific kinds of ratios called rates. Let's look at example number 1. In Mr. Johnson's 6th grade science class, there are 14 girls and 12 boys. Write a ratio in 3 ways that compares the number of boys to the number of students. So first we're going to label our ratio. They are asking us to compare boys to students. So we're going to write boys over students. So we're going to reread the question and figure out that there are 12 boys. And now I need to know the number of students. So to find the number of students, I'm going to have to add the 14 girls plus the 12 boys. So there is a total of 26 students. Now notice that 12 over 26 is not in simplest form, so I need to simplify it. Notice they're both even, so I can divide by 2 to get 6 to 13. I cannot simplify any further because the bottom number is prime. So here's one correct way to write the ratio of boys to students. Remember, I can also write it with the word 2 in between, and I can also write it with a colon between. I want you to try number 2 on your own. So hit pause, work number 2, and when you're ready to check, hit play again. Number 2 says, in Mrs. Kayson's 6th grade reading class, there are 15 girls and 10 boys. Write a ratio in 3 ways that compares the number of girls to the number of students. So I'm comparing girls to students. So make sure that you labeled girls to students. There were 15 girls in the class. 15 girls. To find the total number of students, you had to add the girls plus the boys to get a total of 25 students. You then had to simplify. You should have divided both by 5 to get the ratio 3 to 5. So for every 3 girls in the class, there were 5 students in the class. Then you had to write the ratio 3 other ways. 3 to 5 and 3:5. Number 3 says write the ratio in simplest form that compares the number of scooters to the number of unicycles. Then explain its meaning. So first we need our labels, what we're comparing. Notice scooters comes first, unicycles comes second. So in my ratio, scooters has to come first over unicycles. So let's count. There's 1, 2, 3, 4 scooters, and 2, 4, 6, 8, 10 unicycles. But notice that my ratio 4 to 10 is not in simplest form, so they're both even. So I know I can simplify by 2 to get the ratio 2 to 5. 2 to 5 is in simplest form because they are both prime. So now it asks me to explain its meaning. So the meaning is for every 2 scooters, there are 5 unicycles. So for every 2 scooters, there are 5 unicycles. Number 4 says write the ratio in simplest form that compares the number of oranges to the number of apples. So let's write our labels. We're comparing oranges and apples. Oranges comes first in the problem, so oranges must go on top. And I'm comparing it to the number of apples. So let's count oranges. 1, 2, 3, 4, 5. I have 6 oranges. Now let's count apples. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 apples. But notice that my ratio is not in simplest form. So I can simplify by 2's because both numbers are even. So the ratio 6 to 8 simplifies to 3 to 4. So for every 3 oranges, there are 4 apples. Number 5. Several students were asked to name their favorite kind of book. Write the ratio that compares the number of students who chose fantasy books to the total number of students who responded. So first we need to decide what we're comparing. We're comparing fantasy books to the total number of students. So we're comparing those who chose fantasy to the total number. So notice there were 5 that chose fantasy. Now we need to find the total, so we're going to add all of our numbers together. 7 plus 9 is 16. 16 plus 4 is 20. 20 plus 5 is 25. So there were a total of 25 students who answered the survey. So 25 tells me how many total. So I'm going to divide both by 5. So the ratio of fantasy books to all books chosen was 1 to 5. Number 6. Students have the balls listed in the table available to use during recess. What is the ratio of basketballs to the total number of balls? Please hit pause and work this problem on your own, and then we'll check it. Okay, let's check. You should have compared basketballs to the total number of balls, so you should have labeled basketball over total. There were 6 basketballs, and I had to add to find the total. 2 plus 5 is 7. 7 plus 6 is 13. 13 plus 3 is 16. So my ratio was 6 to 16. We had to simplify. I can divide by 2 to get 3 to 8. So the ratio of basketballs to total balls were 3 to 8. If you got it right, give yourself a smiley face. In your journal, I want you to put a big star, and I want you to write, for unit rate, money always goes on top. So if you were asked to find a unit rate and money's involved, money must always be the top number of the ratio. Number 7. Number 7 says find the cost per ounce of a 16-ounce jar of salsa that costs $2.88. So remember that money goes on top. I'm comparing how much it cost to the number of ounces. So my ratio of money to ounces is $2.88 over 16. Now, I want to know the cost per ounce. Per ounce means for 1 ounce. So I'm going to simplify my ratio until I get down to a denominator of 1. So I notice that both of my numbers are even. So I'm going to divide by 2. I know that 16 divided by 2 is 8. I'm going to come to the margin of my paper and divide $2.88 by 2. Remember to bring your decimal straight up. 2 divides into 2 one time with none left over. Bring down the 8. 2 divides into 8 4 times. 4 times 2 is 8 with 0 left over. Bring down my 8. 2 divides into 8 4 times. That's 8 with none left over. So my equivalent ratio is $1.44 to 8 ounces. Now I notice that they're both even again, so I can keep dividing because my denominator is not 1 yet. So I can divide both numerator and denominator by 2. 8 divided by 2 is 4. I'm going to come to my margin again, and I'm going to divide $1.44 by 2. Bring my decimal straight up. 2 will not go into 1, but 2 will go into 14 7 times. 7 times 2 is 14 with none left over. I'm going to bring down the 4. 2 goes into 4 2 times. 2 times 2 is 4 with none left over. So now I have 72 cents over 4. I know I can simplify by 2 again because both of my numbers are even again. So 4 divided by 2 is 2. And I'm going to come to the margin again and do my 72 cents divided by 2. Bring my decimal straight up. 2 will not divide into 0. 2 will go into 7 3 times. 3 times 2 is 6 with 1 left over. Bring down the 2. 2 divides into 12 6 times. 6 times 2 is 12 with none left over. So now I have 36 cents over 2. Still, my denominator's not 1 yet, and I notice that both of my numbers are even, so I know I can divide by 2 again. 2 divided by 2 is 1. We know that half of 36 cents is 18 cents. Now my denominator is a 1, so my unit rate is 18 cents over 1 ounce. Question number 8. Number 8 says the outside temperature rises 33 degrees in 4 hours. Find the temperature increase for 1 hour. So I'm comparing degrees over hours. My ratio of degrees to hours is 33 to 4. And I want to find out how much it's going to increase in just 1 hour. So I'm going to put a 1 down by hours. So I ask myself, what do I do to get from 4 to 1? And you're correct. I'm going to divide by 4. Now some of you would say, well, you can't do 33 divided by 4. I can divide 33 by 4, but 4 will not divide evenly, so that's okay. We're going to have a decimal for an answer. So we're going to come to the margin and divide. We know that 4 divides into 33 8 times. 8 times 4 is 32, with 1 left over. Since I have a remainder, I'm going to add a decimal, bring it straight up, and add a 0. I'm going to bring my 0 down. 4 divides into 10 2 times. 2 times 4 is 8, with 2 left over. Remember, I can't have a decimal and a remainder, so I add another 0, bring it down. 4 divides into 20 5 times, with none left over. So my temperature rose to 8.25 degrees each hour. You have a total of 8 problems for your independent practice. So please divide your notebook paper, your next blank page in your journal, into boxes. Hit pause and answer questions 1 through 4. When you're ready for questions 5 through 8, you may press play again. Here are questions 5 through 8. Make sure on questions 5 through 8 you are finding the unit rate.